All right, let's keep going. We left off on number 64. So, here we go. Next one is 65. So, 65. Let's do this. On 65, show them on the screen. Okay. 65. Lexin's a plastic used to make one of the compounds used to make Lexin, phosphine, poisonous, decomposes by the reaction. COCl2 gas is in equilibrium with CO gas plus Cl2 gas. And they tell me that Kp equals 6.8 times 10 to the negative ninth, which is small. That's key, it's small. So, pure phosphine at an initial pressure of 1 decomposes, calculate the equilibrium pressure of all species. So, initial, I got 1.0 atm, decomposition, so 0, 0, change, minus x, plus x, plus x, e, 1 minus x, x and x. So 6.8 times 10 to the negative ninth equals x squared. Because this 1 over x, this x is going to 0. So it's really just x squared over 1. Take the square root of both. And you end up getting x equals 8.2 times 10 to the negative fifth atm. But they're asking for on 65 equilibrium pressures of all species. So this is going to be for CO, it's going to be for Cl2, and then I have to do 1 minus that to get the other one. But because it's so small, 1 minus that is basically 0. So, COCl2 is essentially 1 atm. So that's 65. Next one is 67. Ooh, 67 is kind of fun. I think I can fit it here. On 67, they give me a Kp, which is equal to 2.9 times 10 to the negative third, and they give me an equation. So NH4 OCONH2 solid is in equilibrium with 2NH3 gas plus CO2 gas. So initial, not part of it. I got 0, 0. Change, not part of it. Plus 2x plus x. E, not part of it. 2x and x. So that means that 2.9 times 10 to the negative third is equal to 2x squared times x, which is equal to 4x cubed. So divide by 4, take the cube root, X ends up being 0.09 atm, which is equal to the pressure of CO2. But 67 asks for the total pressure. So I have to do 0.09 plus 2 times 0.09 because 2x. So 0.09 plus 2 times 0.09, which is 0.18, equals 0.27 total ATM. So 67, you just had to add them up. 0.09, 2 times 0.09, add those together, you get 0.27 ATM. So that was 67. Next one is 71. So 71. Predict the effect each of the following will have on the equilibrium. So I might just do this one in my book. So 71. Let's see. Don't know if I can even get it there. There we go. So on this first one, additional is added. So additional UO2 is added. Well, that's a solid. So none. B, the reaction is performed in a glass reaction vessel. HF attacks and reacts with the glass. Well, that means I'm going to have less of this reactant. If I have less reactant, it's going to be shift left. Water vapor is removed. That means I have less product. So that means it's going to shift to the right. That's 71. Next one is 74. So 74A. On this one, predict the shift in equilibrium as volume is increased. If the volume is increased, that means the pressure is decreased, which means it's going to shift to the side with the most moles of gas. So 74A, I have 4 moles, 2 moles, so 74A is going to be left. B, I have 1 mole, I have 2 moles. So this one's going to be right. C, 2 and 2. None. D, 1 mole, 2 moles. Most is right. E, solid gas. So the most moles are on the right. Here we go. 75. How will this system at equilibrium shift in each of the 5 following cases? CO2 is removed. Well, on this one, if I remove CO2, CO2 is a product, so right. Water vapor is added, that's a reactant, so right. In a rigid reaction container, the pressure is increased by adding helium gas. Helium is inert. None. D, the temperature is increased. The reaction is exothermic. Well, if it's exothermic, that means that I am going to write plus heat here. So that means I'm adding product. So this one's going to shift to the left. And last one, the pressure is increased by decreasing the volume. So it's going to, pressure is going up. Shift to the side with the least amount of moles of gas. 1, 2, 1, 2. They're the same. So this last one is none. That's 75. 76. What will happen to the number of moles of SO3 in equilibrium? Oxygen gas is added. That's more product, so I'm going to get more reactant, so it's going to increase. The pressure is increased by decreasing the volume. Pressure goes up, shifts to the side with the least amount, so it's going to shift to the left. So this one, it's going to increase. In a rigid reaction container, the pressure is increased by adding argon gas. inert, none. Temperature is decreased, it's endothermic, plus heat. So on this one, it's going to shift to the left, so more. Gaseous sulfur dioxide is removed. I'm removing my reactant, so it shifts to the right, so less. That's 76. 77. In which direction will the position of the equilibrium shift on each one of these? So on these, H2 is added. That's product. Left. I2 is removed. That's product. It's going to shift back to the product's right. HI is removed. That's reactant, so it's going to shift back to the left. Argon is added. That is inert. None. The volume of the container is doubled. Volume is going up, so the pressure goes down. So it's going to shift to the side with the most amount of moles of gas. Well, they're both 2 and 2, so E is going to be none. Temperatures decrease, the reaction is exothermic, plus heat, means I'm removing product, so it's going to shift to the right. Last one, 78. What will happen? H2O is removed, so that is a reactant, so it's going to shift back to the reactants, left. Temperature is increased, it's endothermic, so plus heat. Am I still on the screen? Yes. I'm adding more reactant, so right. Inert gas is added, that's none. CO gas is removed. I'm removing product, so that's going to be right. Volume of the container is tripled. That means the pressure is going down to a third. So it's going to shift to the side with the most moles of gas, 3, 4, 2. So it's going to shift to the right. That is up to 78.